Good morning student, myself Millie Sakla, and in our subject structure analysis part 1, today we solve the example of strain energy. Okay, now we solve our next example. Here in first session we solve the example of a different type of loading and also sudden load. Now in this example we cover impact load. Okay, 1500 mm long wire of 25 mm square area hang vertically. It receive a sliding collar of 100 Newton weight and stopper at the bottom. That means this is our stopper and this is sliding load. Collar is allowed to fall on stopper through 200 mm height. Height is given, that means simply this is the case of impact load. Determine the instantaneous stress induced in wire. Here we find out stress and corresponding elongation. Second unknown is our elongation. And also determine the strain energy stored in a wire. Take modulo of elasticity E is equal to 200 gigapascal. So one by one we first of all mention the data here. Our L, value of L is given 1500 mm. Okay, so right here L is equal to 1500 mm. Area is given 25 mm square. Okay, this data is given in example, and load P is given 100 Newton. Second, Young's modulus E is given 200 gigapascal. Okay, and convert into Newton mm square. 1 gigapascal is equal to 10 raised to 3. So write down 200 into 10 raised to 3 Newton per mm square. Okay, now H H is also given. Write down H is equal to 200 mm height. Now put the values. L is given 1500, H is given 200, and load is given 100 Newton. Okay, now first of all we find out stress. So write down here stress, and this is the simplification of impact load. Stress is equal to P by A plus under root of P square, then divide by A square plus 2E PH by AL. Now one by one put the value. P is equal to given 100, area is given 25. Okay, then plus under root this P square is equal to 100 square. Okay, then A square is equal to 25 square plus 2 into E is equal to 200 into 10 raised to 3. Okay, 200 into 10 raised to 3. Then P is given 100 and H is given 200. Divide by area is equal to 25 and length is given 1500. Now simply we solve is solution of, write down here, stress is equal to sigma is equal to first term solution 25 4s are 100, and solution of the second term is equal to 461.89, and my sigma for impact load is equal to 465.89 Newton per mm square. Okay, this is my first answer, stress. Second, we find out elongation. Now what is the equation? Elongation. Okay, second is equal to elongation, and this elongation delta L is equal to sigma L by E. Now one by one put the value. Stress we recently find out 465.89 and L is given 1500, and divide by Young's modulus is equal to 210 raised to 3, and delta L is equal to 3.49 mm. unit of this elongation is mm. Right here, delta L is equal to 3.49 mm. Okay, this is our second example. Sorry, second answer. Now third is strain energy. Right here, third we find out strain energy. Strain energy U is equal to sigma square second twice E into volume. Okay, now volume is equal to area into length. Sigma square, okay, sigma square, right here, sigma square, then twice E into area into length. Okay, now one by one, U is equal to sigma, we find out 465.89 square, and 2 into Young's modulus is equal to 200 into 10 raised to 3, and area is given in data, that is 25, and length is equal to 1500. After solving this, U is equal to 20,348.76 Newton mm. Okay, so my final answer U is equal to, write down, U is equal to 20,348.76 Newton mm. Okay, this is my third answer. Write down here. Okay, this is my third answer. Now next example. Here our example is complete. In this example we find out three values: stress, delta L and U. Okay, now we read next example. In this example, again read the data carefully. Diameter of bar is equal to 20 mm. Okay, here diameter is given and length is equal to 2.2 meter. Attached with a collar at bottom. Maximum stress developed is to, okay, stress is given 180 Newton per mm square, and calculate the maximum value of weight can be allowed to fall on collar 0.2 meter height, and E is equal to this 2 into 10 raised to 5 Newton per mm square. First of all, we convert the all data, and here height is given, that means this is the simple case of impact load. Okay, first of all, Young's modulus E is equal to 2 into 10 raised to 5 Newton per mm square. Second value is height. Height is equal to 0.2 meter. That means 1 meter is equal to 1000 mm. Write down here. So our answer is equal to 200 mm. Clear? Now second value is given, diameter D. D is given 20 mm. Okay, and length L is given 2.2 meter. That means 2000, right here, 2200 mm. Okay, and sigma stress is given 180 Newton per mm square. Okay, now here first of all we find out sigma is given. Okay, so first of all we find out elongation here, right here, elongation delta L is equal to sigma L by E. Okay, height is equal to 200 mm and L is equal to 2200 mm. This value P is unknown here. Here we will find out load. Now one by one put the value. Sigma is equal to 180 and L is given 2200. E is equal to 2 into 10 raised to 5, and after solving this my delta L is equal to 1.98 mm. Okay, we can't take the equation of directly P by A because it is too much lengthy. We use the relation of derivation that we use at time of derivation. Okay, now if you remember, in impact load I explain you work done is equal to our strain energy. Okay, and here we find out, using this relation we find out our load. Work done is equal to, that is P H plus delta L, and strain energy is equal to sigma square then twice E into volume. Now one by one we put the values here. P then H delta L is equal to sigma square then twice E into volume is equal to area into length. Unknown value is equal to P. So P is as it is. H is given 200. Okay, H is given 200. Delta L we recently find out, that is 1.98, and sigma square is equal to 180 square. Okay, and 2 E is equal to 2 into 10 raised to 5. Area is equal to pi by 4 d square. Okay, so right here area pi by 4 and diameter is given 20 square. So right here diameter is equal to 20 square. Okay, and length of bar is given 2200. Clear? Now one by one here we, after solving this, my P load is equal to 277.17 Newton. Okay, after solving this, my load, that is my load, after solving this term, simply first solving this and then divide by 200 plus 1.98, that is 201.98, we get value of load P. Okay, here our example of this impact load is also complete. Okay, today we solve 2 examples. Now in next session we solve another type of example. Just now we stop here. Okay.